Good afternoon, all. In previous session, we have discussed the compression molding and transfer molding process. And in today's session, we are going to complete the rotational molding process and thermoforming processes. Okay. And in today's session, I will complete the first part of this chapter, processing of the plastics. From next session, I will start the welding of the plastic. Okay. Now, just I will take a short review of previous session. Okay, we have studied this compression molding process. This is the compression molding process. Compression molding and transfer molding process. Let me correct something. In previous session, I think I have told you that rotational molding is only used for thermosetting plastic material, but it is not the case. But the rotational molding can be used for thermoplastic material also. Okay. Previously, it is only used for thermoplastic material. Then they have done some research work, and nowadays they are using it for thermosetting material also. Okay. So rotational molding is used for both type of the materials, and compression and transfer molding process we are using it for the thermosetting material. Okay. So please make these corrections. And now I will take the review of this compression molding process. In compression molding process, just I will explain the working principle in short. Yesterday we have discussed it in brief. This is the compression molding process. It consists of the mold, which is divided in two parts. Okay, this is the lower part of the mold, and this is the upper part of the mold. Lower part is fixed. It is fixed, and upper part will be movable. And how it is moved? At this side, okay, guide pins will be there. Two guide pins. One at the right end and one at the left end. Two guide pins will be there, and with the help of that guide pin, we can move this upper mold. Okay, so initially we are taking the raw material in the form of charge, preheated raw material. It will be termed as a charge, and it is taken in the lower half of the mold. Okay, and this mold is heated mold. It is heated mold. In this heated mold, we are taking the charge, and this charge is pressed with the help of this upper mold. Okay, and in this way, this mold is closed for some time. And as it is this material used is thermosetting material, due to that heat and application of the pressure, it will acquire the shape of that mold cavity. And after some period of time, we are opening this closed mold, and with the help of this ejector pin, we are removing the molded part. This is the concept for this compression mold. Okay, this is the simple diagram. This is the charge, then application of the pressure or closing of the mold, and with the help of ejector pin or knockout pin, we are removing the molded part. This is the final component. Okay, some defects may be there, and that defects are corrected by using different operational techniques. Okay, or you can say some finishing operations are performed. So this is the compression molding process. Again, one example, I have explained this, how the flower pot is manufactured. Okay, bakelite material is used for this bakelite. Then these are some advantages, disadvantages. You can go through it. Okay, then these are the applications of compression molding process. Some products. This is the your energy meter casing, then mirror body, then airbrush handles, then buttons, then your plastic tray, dishes, dinnerwares. Okay, different applications are there. Then the transfer molding process. Now, this transfer molding process is done with the little modification as compared to compression molding process. In compression molding process, we are not able to manufacture the complex shaped components. That's why we are going for the transfer molding process. Here, we can give the mold cavity as per our requirement. Means design flexibility will be here. And related to the working principle, it consists of a transfer pot or a transfer cylinder Initially, we are taking the raw material, which is preheated. It will be considered as a charge, and it is taken in this cylinder. Then the pressure is applied with the help of this plunger. Okay, and it will go through the screw and it will enter in the mold cavity. And this mold cavity, we are providing heat. Okay, as simultaneously heat is there, and due to the pressure applied in the this transfer mold, here you can see initially we are taking material and it is pressed. This material will flow through this screw and it will enter in this mold cavity, and it will acquire the required shape. Okay, and after some time it will get cured. Then this mold is opened, and with the help of this ejector pin, we are taking this component out. Okay, this will be our final component. If required, we will do some finishing operations. Now, in this transfer molding, this is the different types can be there. This whichever diagram is visible on your screen, this is for single cavity. Okay, this is single cavity. This is multi cavity. Okay, so basic difference between compression molding and transfer molding is, in compression molding, we are not able to manufacture the complex shaped components, but that can be achieved with the help of transfer molding process. Okay, and here also in disadvantages, you can say that whichever scrap is there, that will be again produced, because some screw and runner arrangement we are using here, and as this process we are using for thermosetting material, we cannot do the recycling. Recycling of material is not possible. Okay, and applications, some manufacturing of bathroom fixtures. Okay, these are plastic fixtures which we are using in the bathroom. These are manufactured with the help of transfer molding process. Then the boat hulls, some components which we are using in aircraft industry. Then wind turbine blades, we can manufacture it with the help of transfer molding process. Okay, so these are some applications. Then we will move towards the next type, that is rotational molding process. Okay, now basically this process is invented for the manufacturing or processing of the thermoplastic material, but after that they have performed some research work, and nowadays some, I think, suppose approximately 15% thermosetting materials they are using. 85% they are using thermoplastic material for this rotational molding process. And this rotational molding process is also termed as rotomolding process. Okay, I will first show you the application, then you can understand the concept easily. So these are a few applications. Rotational molding process is used for manufacturing of the water storage tanks. Okay, then some military utility boxes are there. And then your storage tanks for chemicals, like your urea tank. This is the gas tank or fuel tank. Okay, all these tanks can be manufactured. Now, basically, the material used for this is polyethylene. Basically, polyethylene and PVC materials are used, but nowadays that silicone material can be used from the thermosetting materials. Okay. So now I will explain the basic concept, or these are the steps involved in the rotational molding process. Okay. These are the steps. Now, in the first stage, what we are doing, this is the, you can say that one half of the mold or lower part of the mold. In that, we are taking the raw material, whichever plastic raw material is there, that material is collected in the form of powder. Whichever pellets or granules are available of the plastic material, we are performing grinding operation on it, and we are converting it into the powder shape. Okay, this is the first condition. Whichever raw material is there, we are taking it in the powdered form. Okay, then that mold is closed, Now mold is closed and we are providing heating. Okay. Now please concentrate here. We are providing heating to this powder plastic material, and simultaneously we will start the rotating of this mold, or we will do the rotation, provide rotation to that mold. Okay, and these rotations will be in along the two directions. Okay, rotations will be along two directions. Means simultaneously heating will be provided and that mold will be rotated. Now what will happen? Whichever powder particles are there, they will start, you can say melting, or you can say that it will become pliable. Pliable means what? Now you can change its shape. Now you can change its shape. Now, as we are providing simultaneous heat and a rotation also, what will happen? Whichever raw material is there in this mold, due to the rotation, it will get attached to the wall of that mold. Are you getting this? As we have provided heat and we are rotating that mold along two directions. Okay, you can say this vertical direction and this horizontal direction. Rotation and heat simultaneously we are performing it. Due to this, what will happen? That plastic powder, it will get attached to the walls of this mold and a layer will be formed. One thick layer will be formed, and we will provide some cooling time here. In case of thermoplastic material, we will provide cooling, and some cooling medium will be used. Either we are going to use the water as a cooling medium, or simply the cooling is done with the help of air medium. Okay, water and air. Initially water cooling will be done, and in the last stage we are going to remove, or we are going to open that mold. Upper half will be removed, and that whichever particle or component is manufactured, it is taken out, and we are keeping it in the air, so that final cooling operation will occur and we will get the final product. Okay, in this way rotational molding process is completed. Are you getting this? I will explain it again. The first stage is named as the charging. Okay, means the plastic material will be grinded and it will be converted into powdered form, and it is taken in the upper half of the mold or one part of the mold. Then we are closing that mold and simultaneously heating and rotation along two axes. Okay, rotation will be along two axes in this direction. Okay, vertical and horizontal. One time we will rotate like this, and another time will be like this. Okay, these two directions rotations will be provided, and due to rotation, this powder particles will get attached to the mold wall. Okay, and after cooling for thermoplastic material, or by providing some curing time for thermosetting material, it will be removed from this mold and final component is obtained. So this is the rotational molding process. Okay, please draw this diagram. Okay, this diagram is not available in the book. I have collected from the online sources. Please draw this. If you are having any doubts, you can ask me. Those who are attending through online mode, you can put your queries in the chat box. And those who are attending through offline mode, you can ask directly. Okay, I will provide you 1 or 2 minutes time. Please draw these steps involved in the rotational molding process. Okay. Okay. Now we will move towards the next point. So after this working principle of rotational molding process, we will move towards the advantages, its advantages, some disadvantages, and applications. Okay, so these are the advantages of rotational molding process. Okay, please concentrate here. So in this rotational molding process, whichever tools we are using, these are having low cost. Okay, whichever tooling cost is there, it will be very minimum as compared to the other processes, and whichever that mold is there, we can use the aluminum material mold here. Okay, aluminum material mold can also be used. For making the mold, we can use different materials. We can go for steel or stainless steel or alloy steel, or you can go for aluminum and its alloy. Okay, in this rotational molding, whichever mold material is there, we are using the aluminum, and it is having comparably, it is having low cost. That's why the tooling cost will be very less. Then, in case of this rotational molding, whichever wall thickness is achieved, we will get the uniform wall thickness throughout the component. As in case of you can see the compression molding process. Somewhere we will not able to get the uniform thickness of the parts. But in case of rotational molding, we can achieve the uniform thickness. Then in this rotational molding process, for example, if you have seen the water storage tanks which we are using in our home, you may have read the on its logo or on the front side, they have written that 4-layer, 3-layer water tanks. If we are using that supreme water storage tank or that Syntex 3-layer, 2-layer, like this wording is there, means you can give the layers of that material. Layer by layer you can manufacture it. To manufacture very thick tank, for example. Are you getting this? Means we can manufacture it with the help of layer by layer structure. And as this layer by structure is there, it will provide you longer stability as well as longer durability. Its life will be very long. Okay, high durability, then high stability will be there. Then its strength is also very high. Then appearance. Okay, you can see that its surface finish is very good. Whichever storage tanks are there, or that pallets or crates we are using, it is having very fine surface finish. I will show you some examples. Okay, whichever storage tanks are there, then you may have seen this road barriers. Means surface finish is very smooth. Means appearance is very much attractive, and it is one of the advantage. So these are some children's slides in gardens. We are seeing this. Okay. Then related to the disadvantages of this process, the very big disadvantage is related to its cycle time. Okay, its cycle time will be very high. Means it will take lots of time to manufacture one single component. Okay, here it is highlighted with the high cycle time. Then the raw material, very limited raw materials can be used, as we are converting the raw material into powdered form. First, we are grinding the raw material and we are forming the powder. Some plastic materials are there. It is very difficult to do the grinding operation on it. Okay, some thermosetting materials are there, and it takes more time, or it takes more energy and money also. Okay, so you can add that in the disadvantage. Then cost of raw material is very high. because it requires some thermal stability. Then repeatability is very low. Okay, and labor cost, high labor cost is high because certain amount of skill is required. Whichever labor is there, you have to give some training so that he can operate it in a good way. Okay, means skilled workers are required here. Highly skilled workers are required, and that's why it becomes a high labor. Means it will result in the high labor cost. Okay, skill is required because some automation will be there, mechanization or automation is involved. Hence, you have to provide some amount of training to the laborers. So you can mark it as a disadvantage. Then these are the advantages: manufacturing of water tanks, then military utility boxes, then gas tanks, fuel tanks, then urea storage tank, then the road barriers and children's slides, then crates, pallets, and dustbins. Okay, these are pallets. This is pallet. These are crates, which we are using for handling of the fruits or vegetables for storing. Okay. Then these are kayaks and boats. This is kayak. And these are boats. Okay. Then fertilizer boxes are there. Mobile toilets. All these are manufactured with the help of this rotational molding process only. Okay. Mobile toilets, then fertilizer box. This is kayaks and boats. Okay. Dustbin. This is pallet, and these are crates. Okay. Why I am showing you pictures, you can remember it very easily. If I will show you just names, it's not possible to recall it. Okay. So all these products can be manufactured with the help of rotational molding process. Okay. So in this way, we have completed this part, rotational molding process. Now we will move towards the last processing method, and that is the thermoforming process. Okay, so this is the thermoforming process. If you are having any query, please ask me. Okay, this is the last processing method for this plastic materials. Now, in this thermoforming process, what we are doing here, initially we are just taking the plastic sheet. Okay, plastic sheet will be collected. Okay, plastic sheet will be collected, and that plastic sheet will be converted into the different shapes, three-dimensional shape product. Okay, from plastic sheet we are manufacturing the products. Suppose one dish is there, dish or plate is there. It is manufactured from the sheet only, and to manufacture it, we have to perform this thermoforming operation. Okay, now this thermoforming operation can be performed in different ways, or it has three different types. Okay, one by one we will discuss it. Just I will name that types. The first type is vacuum forming, then mechanical forming, and pressure forming, or vacuum thermoforming, mechanical thermoforming, and pressure thermoforming. We are having these three types of thermoforming processes. Now, initially, I will explain the working principle of this thermoforming process. Okay. Initially, it requires two steps only. First is the heating, and second stage is the forming. Forming is nothing but application of the pressure. Or in short, you can say that it consists of only two steps. One is the heating and one is the pressing. Okay. Now in the first stage, what we are doing, we are taking the plastic sheet. And to manufacture that plastic sheet, we can use different methods. Which method will be used for manufacturing of the plastic sheets? Plastic sheet can be manufactured by using. Okay, I will show you the previous diagrams. Okay, this one is there. Calendaring method can be used, or you can go for extrusion also. With the help of extrusion molding process or by performing the calendaring operation. Okay. Now after extrusion only we are performing calendaring operation. Okay. Means we can form the sheets or films using the extrusion process, or with the help of this calendaring operation we can form the sheets or films as per our requirement, and that sheets are further converted into three-dimensional components or products using thermoforming process, and it consists of whichever sheet is there which is manufactured at the end of extrusion or at the end of calendaring operation. That sheet is taken and it is fixed in I will show you this with the help of this diagram. That sheet is collected and it is clamped. Okay, with the help of these clamps we can clamp it, or it is fixed. Okay, this is the first stage. Okay, clamping of that plastic sheet and heating of that plastic sheet is done. This is the first stage. Okay, please listen carefully. These three types will be just we are changing the medium for application of the pressure. Remaining part will be same. Okay, whichever three types are there, just application of pressure will be in different way. Other part will be same. Okay, in the first stage, what we are doing, we are taking the plastic sheet and it is clamped with the help of these clamps, or it is simply you can say that plastic sheet is fixed with the help of clamps and heating is done. This plastic sheet is heated. This will be termed as preheating. Okay. Why this preheating is done here? Due to that preheating, that material will become pliable. Pliable means what? You can change its shape now. Okay. So preheating is done, and after sufficient preheating, that sheet will become pliable. And when that sheet becomes pliable, then it is placed on this mold like this. Okay. It is placed and pressure is applied. Just simply what we are doing, we are applying the pressure. Now, when the pressure is applied from this top side, okay, the compressed air or simply air pressure is applied, then due to this air pressure, what will happen? That sheet will be pressed against the mold walls and it will acquire the shape. It will acquire the shape. Whichever shape you want to convert it, that shape you have to give to the mold. Okay. So these are the steps involved in the pressure thermoforming or simply thermoforming. And now I will explain how that different types are or names are given when the pressure is applied with the air medium. And before application of the pressure, whichever air is there in this mold, it is removed with the help of this vacuum pump. Okay. And then pressure is applied, then it is due to this pressure, whichever material is there or whichever sheet is present, it is pressed against the mold walls and it will acquire the required shape. I will show you one example. You can see here one example. This is your finished product. Plastic box or plate is manufactured here. Okay. Initially, sheet is taken. Okay. Then this sheet is preheated. and we are placing it on this mold, and we are taking the whichever air is there in this mold box, that air is initially removed, and then pressure is applied by using the compressed air. Okay. Due to this pressure or due to this air, that material or sheet will be pressed against this mold wall, and it will acquire the required shape. Okay. After some time, this mold will be opened and this component is removed. Okay. Are you getting this? We are not using any cooling medium here. Hence, we can say that we can use this process for thermosetting materials. Okay. We can do the means from sheet, just we are manufacturing the, or we are giving the three-dimensional shapes. Only two steps will be there: heating of that sheet and pressing. And for pressing, we are using the different medium, and depending on that, three types are there. The first type is pressure thermoforming. Okay, already I have explained this. Then second type, vacuum thermoforming. Okay. The first stage will be similar in all types, all three types. Initial steps will be same. Okay. Sheet is collected, it is fixed in the clamp, and preheating is done. That sheet is heated and it is placed on this mold. Now, here, whichever pressure is there, that pressure is created by the vacuum pump. Okay. With the help of this vacuum pump, all air is taken out. Okay. And that pressure is very high. Okay. It will be taken out. Are you getting this? It will be act as a suction pump. Okay. And due to this, pressure will be created and it will get pressed against this mold wall. This is the vacuum thermoforming. Are you getting this? So this is the example. Same example, we can manufacture the same plate or that plastic box with the help of this vacuum thermoforming process. Okay. This is the sheet. It is clamped. Then that sheet is heated. That heated sheet will be placed on the mold by closing it, and with the help of vacuum pump, we are creating the required amount of force. Okay. Due to this vacuum pump, whichever material or that sheet is there, it will be pressed against the walls of that mold and it will acquire the shape of that mold cavity. Okay. And after some time, it will get cured, and by opening this mold, we will get the finished part or final product. Then third type of thermoforming is mechanical thermoforming. Okay, this is the mechanical thermoforming. Initial steps will be same. Okay, first step is same, that is plastic sheet is taken, it is clamped at the ends. Okay. Then it is preheated and it is placed on this mold. Okay. Then whichever air is there, it is taken out. Okay. Then the pressure is applied with the help of one plunger. Okay. With the help of plunger, we are applying the pressure. Due to this plunger pressure, whichever sheet is there, that sheet material is pressed against this mold wall and it will acquire the desired shape. And after sufficient curing, this plunger will be removed and we will get the finished product. Okay. In this way. This is your plastic sheet. Here preheating is done. Then it is placed on that mold and pressure is applied with the help of the plunger. Okay. Then it will acquire the desired shape. And by opening the mold and removing this plunger, the final product is obtained. So this is the mechanical thermoforming process. So this is the concept of thermoforming, and it's three types. Okay, it is very simple. Just we are changing the medium by which we are creating the pressure. Okay, when air medium is used for application of that pressure, it is termed as pressure thermoforming. And just we are using the vacuum or vacuum pump to create that force, then it will be termed as vacuum thermoforming. And when the pressure is applied or force is applied with the help of plunger or mechanical means, it will be considered as mechanical thermoforming. Okay. These are some advantages and disadvantages. Okay. Then remember here, thermoforming process can be used for manufacturing of these different parts like air ducts, bumpers. Okay. These are outer body parts of the vehicles. Okay. And dashboard assemblies, interior door panels, and then sitting parts. Okay. These are different examples. Okay. Okay. In this slide, I have explained the concept in short. You can go through these points. Okay. Heat the thermoplastic sheet till it becomes soft. Okay. This is basically for thermoplastic material. And force the hot and pliable material against the counter of a mold by using either mechanical, air, or vacuum pressure, and held against that mold, and we are providing some time for cooling, then it will acquire the shape or retains that shape. Okay. So this is the thermoforming process. So in this way, the processing part for the plastic material is completed. From next session, we will start the welding of the plastic material. Just within a few minutes, I will take a review which methods we have discussed. Okay, we have started with this. Okay, so this is the list for processing methods of the plastic materials. And this we have started with injection molding process, and its two types. We have discussed the basic working principle, then its steps involved. Okay, two types are there. Okay, ram type and screw type. These are advantages, disadvantages, and applications. Manufacturing of different boxes, chairs, then toys. Then extrusion molding process is manufactured, or it is used for manufacturing of your window frames, hose pipes, garden trellis, adhesive tapes. Okay, so this is the extrusion molding process working principle, and this is not the end of the process. After this, we are performing the cooling and some size rectification operations, and it is collected as per our requirement by performing some cutting operation. The extrusion process has these three types. Solid product, when solid product is manufactured, it is termed as solid extrusion. Hollow product is manufactured, hollow extrusion. And when we are manufacturing two components, and when they come out from that die opening, suddenly we are performing joining operation, and then cooling is done. It will be considered as co-extrusion. Okay. Here you can see in this process, two or more extruded products coming out through the multi-opening dies are joined or welded before cooling process. This is the co-extrusion. Okay. These are applications: insulating wires, pipes, tubes. These are hose pipes, garden trellis, adhesive films, window frames. Okay, these points you can go through it later. Okay, calendaring operation, what we are doing here, that's whichever sheet is formed at the end of extrusion, we are converting it as per our requirement of the thickness. We can convert it into thin sheets or thin films also. Okay, and here we are using the set of rollers, and when set of roller consists of more than two rollers, it will be termed as calendar. And from that, the name given is calendaring. Okay, so this is the cycle, and different rollers are used here. This can be used for polyethylene material or PVC material. Then thermoforming process, today only we have discussed it. From that sheet, we are manufacturing 3D components. From sheet, we are manufacturing 3D components by application of heat initially and then pressing it by using air medium, vacuum medium, or by mechanical pressure. Okay. There are some advantages, disadvantages, we can go through it. Then we have discussed the blow molding process. Basically, it is used for manufacturing of the hollow components, like your plastic bottle, then water jars, water storage jars, or tanks. Okay. Now, in this, basically, we are having the parison or preform, and that parison or preform is manufactured by injection molding or extrusion molding process. Then it is placed in the mold parts. Then mold is closed, and from one opening, there will be one opening to the parison. Through that, compressed air will be allowed to enter, or we are performing the blowing operation. Okay. Due to this air, that material will be pressed against the walls of the mold cavity, and after some time or after sufficient cooling, it is removed. Okay, some defects may be there. That defects can be eliminated by finishing operations. Okay, so there are different types of blow molding process, like extrusion blow molding process, injection blow molding process, and stretch blow molding process. And they are having some subtypes also. Single stage means all the operations are performed on a single machine. Okay, preparation of parison, then closing it, then blowing, cooling, and ejection. All these are performed in a single machine. And if we are performing it on different machines, then it will be considered as two-stage or intermittent molding process. Okay. Then these are the diagrams for these all three types. These are the applications. Some toys, then bottles, okay. Then storage tanks, then cosmetic storage tubes are there. Pharmacy PET bottles are there. Okay, all these are manufactured with the help of blow molding process. Then for thermosetting material, we are using compression transfer molding. Basically, these two are used, and we can nowadays they have given some data related to the rotational molding also can be performed on thermosetting materials. Okay, so in compression molding, we have discussed this. Charge is taken and it is pressed. Okay, and after sufficient pressing, we are removing it, and with the help of ejector pin, that component is obtained. These are the stages. And very much similar to this, transfer molding is performed. Okay, here just screw is used to transfer this charge to the mold cavity. Hence, the name is given as transfer mold or transfer molding process. Okay, it has different types transfer molding process that we are going to cover in 4th chapter. Okay. Okay, here only two diagrams I have explained: single cavity transfer molding and multi-cavity transfer molding. And after this, rotational molding process is there, or rotomolding process. It consists of different steps. Raw material is taken in the powdered form. Okay, then the mold is closed and heating is done, and simultaneously we are rotating that mold in two directions, or biaxial rotation is done. Okay, due to that, what will happen? Whichever powder is there, it gets attached to the mold walls, and after sufficient cooling, that mold is open and product is taken out. Okay, so it has some advantages, disadvantages, and these are the applications: water tank, utility, military utility boxes, then gas tank, fuel tank, urea tank, road barriers, crate, pallets, dustbin. Okay, then kayaks, boats, mobile toilets, and fertilizer boxes. Okay, so in this way, we have completed this processing of plastics. From next session, we will start the welding of the plastic materials. So you can enter your roll numbers in the chat box for the attendance purpose. Those who are attending through online mode, please enter your roll number in the chat box.